Hello everyone! Today we're going to be talking about rational exponents. Okay, so do you remember this symbol, this thing right here? Well, what is it used for? And what does it do? Well, whenever you have a radical symbol and a number underneath it, okay, right now it's asking for the square root because it's an understood square root. There's an understood 2 in the right here. We'll talk about what those numbers mean in a minute. But what it's asking for is for how, like, what number multiplied by itself gives me 9? Okay, what number squared gives me 9? Well, that would be 3, right? Because 3 times 3 equals 9. Okay, well, here's a fun fact. There are many other roots that we can take. This is a square root, and the square roots are the most basic and probably the most familiar to you. And we've talked about these in the fall. Okay, but just like we can take the, like we can do 3 cubed or 3 to the 4th, we can take the cube root of, well, this would be 27, and the 4th root of 81. And both of these would be 3, because 27 is 3 times 3 times 3, and 81 is 3 times 3 times 3 times 3. Okay, so basically we've got all these neat roots that we can take. So let's talk about how we know which one we're taking. The index is the small number to the left of the radical symbol that tells you which root to take. Right? So for example, this guy right here, that is the index. He's telling us we need to take the cube root of 8. Okay? So what number multiplied by itself 3 times, or what number, it's asking us what number cubed equals 8 is really what it's asking us. Okay? Well, we know that 8 has factors, so let's factor 8. 4 and 2, and 4 is 2 times 2. So 8 is really 2 cubed. So what is the cube root of 8? Well, that would be 2, because 2 cubed is 8. All right? Another way to write an nth root is by using rational exponents. Oh yes. Recall, a rational number is a number that can be written as a fraction. Oh yes, fractions are back. Now, so we're talking about the word rational. Rational means fractions. So we're going to use fractions to write with exponents, because notice here we wrote 2 cubed is 8, right? And we were looking for the cube root of 8. So I should be able to write something around 8 to give me 2. We're going to rewrite each rational exponent as a root. All right, so this guy is saying, okay, I want to take the cube root of 8. All right, so I'm going to rewrite this as the cube root of 8. Okay, this is 2. We've already seen that. Okay, this one's saying the 5th root because he's in the denominator. So this is the 5th root of 32 plus the square root of 9. Well, we know what the 5th root of 32 is. We know that 2 to the 5th is 32, and I can verify that. 32 is 8 times 4. 4 is 2 times 2, and 8 is 4 times 2, and 4 is 2 times 2. So how many 2's are there? 1, 2, 3, 4, 5. So 2 to the 5th equals 32. So the 5th root of 32 is 2, plus the square root of 9, which is 3. So this is 5. 2 plus 3 is 5. Right? So that's how you do that. Notice there's not a 2 on the outside of the radicand. Since square roots are so common, we just understand the radical by itself to just be the square root. All right, let's try this one. This one's asking for the 4th root of 16. Well, 16 is 4 times 4, and 4 is 2 times 2, 2 times 2. So there are 4 2's in 16. So that means 16 equals 2 to the 4th. So what raised to the 4th power gives me 16? That would be 2. Okay? All right. Essentially, rational exponents are fractional exponents. Oops. Where the numerator is the power and the denominator is the root. Okay, so this is how I remember it. I think of the top being the ultimate cosmic power. Leaving space, because they're in the exponents, right? All right, and the bottom is the root. Just like in trees, you've got a root and then the bottom of the tree underneath the ground. Okay, so roots are in the denominator, powers are in the numerator. Top is power, bottom's root. Power, root. Okay? So, we're going to identify the power and the root of the rational exponent, and then we're going to rewrite in radical form. Okay, so which one's the power? Well, here, 2 is the power. Okay, so we're going to raise it to the second power, and 3 is the root. Okay, I'm going to make sure we understand this. So I'm looking for the cube root of 8, and then raise it to the power of 2. So I'm going to cube root 8, and then raise it to the second power. Now these could be done in either way. I could also write 8 squared, and then cube root that. Both answers are the same. All right, let's try this one. Which one's the power? Well, if you said 3 is the power, you were right. So the power is 3. The root is 2. So I want the square root of 9 raised to the third power, or 9 cubed and then square root that. Okay, just like we just saw, there are two different ways of evaluating rational exponents. The first way is to raise the number to the power first, then take the root. Okay, for example, let's say I have 4 to the 3/2. Okay. Well, what if I did 4 cubed first and then took the square root, the 1/2 power? Well, 4 cubed is 64. Okay, so that's 64 to the 1/2 power. Well, the square root of 64 is 8. Okay? This is a little hard, in my opinion. I don't like this way at all. Because notice you're getting the number to be bigger to take the square root. My favorite way is usually easier. If you take the root first, then raise the result to the power, you get smaller before you get bigger, and it's easier to take the stuff. So like, for example, if I have 4 to the 3/2, I'm going to take the root first. So I'm going to take the square root of 4 first, and then cube it. Well, the square root of 4 is 2, and 2 cubed is 8. Ta-da! I like this way a lot better. As you can see, it's much easier to cube 3 than to cube 4. So I like cubing smaller numbers. It's easier for me to do in my head. All right, so let's try these. This one says 84 to the 5/4. Well, let's do this my way. We'll do it way 1 and way 2. Okay, and you can make your own decision which one you prefer. All right. The first way is taking 81 and raising it to the 5th power, and then taking the 4th root of that. Yeah, I'm not going to actually do it that way. I'm going to take the 4th root of 81, and then I'm raising that to the 5th power. Well, 4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. I could even do that by checking and making sure. 9 times 9, and that's 3 times 3 and 3 times 3. There are 4 3's multiplied in 81. So that means 3 is the 4th root. So this equals 3 to the 5th power. Well, 3 to the 5th power is 81 times 3, which is 243. Okay, so that's my answer. Over here, I'd still be trying to find the 5th power of 81 because I can't cube that raise 81 to the 5th power in my head. So this is way 2 is generally a lot easier. Here again we would have the same problem trying to square 3,125. That's just not practical. So I'm going to take the fifth root of 3,125 and then square it. Now I don't know what the fifth root is, so I'm going to go ahead and factor 3,125. I know that 5 is a factor because 5 is the last number, so I can take out a 5. So 3,125 divided by 5, that would give me 6, 12 left over, that's a 2, 25 is a 5, so 625. Again, I can take out another 5, and that would be 125. Right? I can take out another 5, and that would be 25, and then take out another 2 5s. So 5 to the 5th power equals 3,125. Okay, so what I have here is 5 squared, which is 25. Much nicer. Okay. All right, do you remember this? When you take the square root of something squared, you get two possible answers. You get the positive answer and the negative answer. Well, this is very important. This means that if you take the square root of a number that is positive, because x squared is positive, then the answer is also positive. Okay. However, this stuff inside, if I take the square root of x squared, all right, I could have, well, if I have x squared equals some number, and I take the square root of both sides, then x equals the positive or negative of that square root of that number. Okay, so this is very tricky. We'll get into that later. Okay, so here's some examples. When x is positive, all right, and n is even. So for example, we would have 2 squared, positive and even, or I could do 3 squared. Okay, x to the n is positive, and the nth root of n squared is positive. Okay, so here's another example. If I have a negative number raised to an even power, so like negative 3 squared, okay, then negative 3 squared is positive. And this is the square root of negative 3 squared. Well, when I square negative 3, it becomes positive, so now my square root's positive. Okay, now this gets a little iffy. Notice I'm asking for the positive root, okay, if it's positive. I'm not asking for the plus or minus. So in this situation, yes, it would be positive. Later on, we're going to get into some issues with this. Okay? So let's say you've got a positive x, so like 3, and I'm raising it to an odd exponent. Well, 3 to a positive number raised to any exponent is positive. Okay? And if I take the nth root of a positive number, I'm also going to get positive. Now here's the tricky one. All right? If I take a negative number and I raise it to an odd power, then if I multiply negative 3 times negative 3 times negative 3, I get negative 27. All right? So this means this is negative. All right? And my cube root would also be negative. Okay, so when you have even powers, in even roots, you're going to get positive answers for the most part. Right now we're just talking about positives, so yeah. Here, where you've got odd powers, you can have negative roots. Okay? So let's try this. We're going to assume all of these numbers are non-negative, okay? So either 0 or positive. So here we have a to the 4th power and the 4th root. Now remember, the fourth root is the same thing as raising it to the 1/4. Okay, because 1/4 is the same as the fourth root. The reason I'm saying do this is it's so much easier to go ahead and now it's just an exponent. We can use our exponent rules. Remember, when you raise a power to a power, you multiply the exponents. So this is a to the 4/4, b to the 20/4. All right, remember when you multiply fractions, you're just multiplying across, so 20 over 1 times 1/4 is 20/4. Now we can reduce the fractions. Well, a to the 4/4 is a to the 1, and it's an understood 1, so I'm not going to write it. And b, 20/4 is 5. So this is my answer, a times b to the 5th. I like that. All right, here we're going to go ahead and distribute the power, or not distribute, we're going to raise each of our bases to that power since we're multiplying in the middle. So I've got x to the 6th over 2, y to the 4th over 2. And here I'm going to go ahead and write it as y squared to the 1/2. Okay, so we have x, 6 over 2 is 3, 4 over 2 is 2, and y squared to the 1/2 is y squared over 2. And that would give me x cubed y squared times y, and y squared times y, you add the exponents, so that's x cubed y cubed. Love it, right? So here's some pictures, my citation page. So what to do next? Go to Edmodo, and under 7.5 rational exponents, click on Turn It In. In the response box, please answer the following questions. These are your questions you need to answer. What is a rational exponent? And what do the numerator and denominator represent? Okay. You need to understand this concept from this video. If you're still uncertain, go ahead and watch the video again, or at least the parts that talk about rational exponents, the very beginning. You need to give me one good question unless you have more. If you are completely satisfied with how you understand this material, don't worry about asking a question. And don't forget to bring in your notes, your warm-up, and your cool-down for class. All right, I will see you guys later.